Hello everyone and welcome back to CodeChef. In this video, we are going to move beyond basic SQL concepts and explore some advanced and extremely important topics that are widely used in real-world database design. We will start by understanding advanced keys in databases, including composite keys, candidate keys, alternate keys, and super keys. After that, we will learn how to combine data from multiple queries using union and union all and understand when to use each one. Finally, we will look at the with clause, which helps you write cleaner, more readable and more maintainable SQL queries. So if you want to strengthen your SQL fundamentals and take your database skills to the next level, make sure you watch this video till the end. Advanced keys in database design. First, composite key. A composite key is a primary key made up of two or more columns. So let's suppose no single column has the potential to become a primary key because of repeated values. But a combination of two or more columns can uniquely identify each record. So we make a combination and set it as primary key. So such kind of primary keys are known as composite keys which have two or more columns. Example, create table marks in bracket student ID int, comma subject ID int, comma marks int, comma primary key in bracket student ID, comma subject ID, then bracket close and semicolon. So here we are setting a combination of two columns, that is student ID and subject ID, as primary key. That is why this is known as a composite key. Candidate key. A candidate key is a column or it can be a set of columns that can become a primary key. So let's suppose we have two columns, student ID and email, in a table where the values for both student ID and email are unique. So they both have the potential to become a primary key. So they are both candidate keys. Next is alternate key. An alternate key is a candidate key that is not chosen as the primary key. If student ID is primary, then email becomes an alternate key. So as we discussed, there can be multiple candidate keys for a table. That means there can be multiple columns can uniquely identify all the records. But one table can have only one primary key. So the columns which are candidate keys but are not chosen as primary key are basically known as alternate keys. That means they have the potential to become the primary key but they are not primary key for the table. Super key. A super key is any combination of columns that uniquely identifies a row. Example, student ID or student ID comma name or student ID comma email. So any combination of columns that can uniquely identify a row is basically a super key. Now every primary key is a super key. Why? Because every primary key can uniquely identify all the rows which are there in the table. But not every super key is minimal. Union in SQL. Union in SQL is used to combine results of multiple select queries. We use the concept of union to merge the results of multiple select queries or merge the values of multiple tables. Now there are some rules to use union. First, the tables that we are combining using union should have same number of columns. Second, columns that we are trying to merge using join should have compatible data types. And third, when we use union to merge two tables, it removes duplicate entries from the table. Example, select city from customers, union select city from suppliers, semicolon. Let us go to the CodeChef platform and see an example of union in SQL. So here we have two tables, table MFGIND and table MFGINT. This is just an example for your understanding. So here In table MFG there are two columns for ID and company name. Similarly, in the second table also we have two columns for ID and company name. So both the tables have same number of columns, 2 for each. And if you see ID and ID, these two have same data type, and company name, these two have same data type. When we execute the query, select star from MFG IND union, select star from MFG INT semicolon, then the output will be ID, then company, and the data for both the tables will be visible in one single table. Now let us see what is the task for us. Write a query using union to stack the tables art over science and output the final table. So these are two separate tables, arts and science, and we want to show the result for both the tables in one single table where the column headings will remain same for table science. Select star from arts union, select star from science semicolon. Let us run this query and see the output. Subject ID, subject name. Now as you can see, the first three entries have subjects physics, chemistry, biology. So these must be records coming from table science because these three subjects are branches of science. And the next three entries, economics, history and sociology, must be from table arts because these are all arts subjects. So this is how we use union in SQL. Next is union all. Now what is the difference between union and union all? Union removes duplicates while union all shows result after merging the tables as it is. That means it keeps duplicate values as well. Example, select city from customers. Now instead of union we are writing union all and then select city from suppliers semicolon. Last but not the least, with clause. The with clause allows you to create a temporary data set that can be reused in a query. So it works exactly like joins. If you have seen my previous videos or you have learned the concept of joins, you must know that joins are used to create temporary data set just to fulfill data requirements of the user. It just allows the user to retrieve the information that he or she needs. It does not make any change in the actual data set, but is just used to retrieve data in a particular format. Now the main difference between with clause and joins is that queries with clause are much simpler in comparison to joins. Now let's see what are the uses of with clause. First, it improves readability. Then it is used to avoid repeated subqueries and it makes debugging easier. Example, with high scorers as bracket begin, select student ID, marks from marks where marks is greater than 80, bracket close, select star from high scorers semicolon. So here we are creating a temporary data set in which we are first retrieving the data that should have only student ID and marks column from table marks, and that too only for those rows which have marks greater than 80. And that's a wrap for this video. Today we covered some powerful SQL concepts that play a major role in database design, optimization, and real-world applications. You learn how advanced keys help uniquely identify data, how union and union all allow you to combine results efficiently, and how the with clause simplifies complex queries. These topics are not just important for exams and interviews, but also for writing clean, scalable, and professional SQL code in real projects. Make sure you practice these concepts by writing queries on your own on the CodeChef platform. Thank you so much for watching.